On this page of notes, we're going to continue to talk about capacitor properties and learn a little bit more about capacitors in general. So as it says here, there are three important characteristics that we just need to know about capacitors, really just as something we don't need to think deeply about. We just know that if this is true, this is how it affects capacitance. The first thing we need to know is that you get a larger capacitance if you literally physically use larger plates, and that should make sense based on our parallel plate capacitor discussion, where we were putting positive charge on the top plate. The more plate you have, the more positive charge you can put on it. Now, this one is not as intuitive. So I think one is intuitive. You have a large capacitor, you have a large capacitance. It actually turns out that the smaller the separation distance between the plates will correspond to a stronger energy storage device in terms of the energy that can be released from that device. The energy of a device, we will see, is based on the strength of the electric field between the plates. The strength of the electric field between the plates is increased if D is made smaller. So that should definitely make sense to us, that if D is made smaller, if the voltage is held fixed, that battery voltage, the electric field between the plates increases, and we will see how that corresponds directly to the energy that is stored in the capacitor later on in this unit. Now, because we want the separation to be small, the material between the plates is important because you want a good insulator to hold off what we'll see is electrical breakdown, kind of lightning striking between the two plates, burning through that dielectric. That will ultimately fry the capacitor, ruin the capacitor. So you want a good insulator that doesn't allow that to happen, that holds the voltage off between the top and the bottom plates. In terms of capacitor safety, it is absolutely important that you know capacitors are dangerous. They can store large amounts of energy and for long periods of time. So if you are unsure of electronics, you should never just go poking around in there with your hands, hoping that you are safe. Now, of course, not all capacitors are dangerous, because you can have very small capacitors and capacitance values that are harmless to you, as we will be using here in class together. But in general, they have capacitors that range in size from like nano technologies to massive capacitors that are even the size of classrooms or two-story buildings. They can be enormous in size. Well, capacitors also will sometimes have polarity and sometimes not. Our two metal plates that we talked about, the parallel plate capacitor has no polarity. In other words, it didn't matter whether we connected the battery to the top metal plate or the bottom metal plate. Depending on the material that is between the plates of the capacitor, that electrolytic material for electrolyte capacitors does have polarity, because that material itself forms the positive and negative. It's defined by the electrolytic material. So since the electrolytic material has polarity, the capacitor must have polarity. Now, electrolytic capacitors, since they do have polarity, will always have markings on them. So they'll have markings to designate. There's usually a band. That's why I have the dark band here with the negatives shown to indicate the negative. The negative lead is also always smaller than the positive lead. So you have to connect a capacitor that is defined by polarity, the positive to the positive terminal of the battery and the negative to the negative terminal of the battery. And they're often in the shape of like little cans, so they'll be like little cylinders. Now, the electronics symbol for the battery looks like a capacitor, but it is not quite the same. So the electronic symbol for the battery has the shorter line is our negative terminal, and the longer line is our positive terminal. Some of the other conventions. Now, when a capacitor is fully charged, we have charge on the top plate and the bottom plate. So capacitors will always have the same amount of charge on the top plate and the bottom plate, because as we saw, it's the charge on the top plate that is pushing charge off of the bottom plate. And certainly when we say what is the charge on a capacitor, we are talking about the charge on the top plate only. So we are not saying no net charge because of the positive and negative, and we certainly are not saying double the charge on the top plate. It is only the charge on the top plate which would be the charge on the capacitor. And to give you a little insight into how capacitors are used, or one application for them, anytime you want to have a repetitive discharging of energy, you probably are going to want to look to employ a capacitor. So here we have our battery voltage and our capacitor in place. And without the red, and I'll talk about that in a second, without the red, we just charge the capacitor, we close the switch, charge the capacitor up until it is fully charged. Now, once it is fully charged, the charge stops flowing. It doesn't matter whether this switch is actually opened or closed. Nothing happens either way. So if it's fully charged and we were to open the switch, so we're going to open it back up, and close the red switch, we could take the charge on the capacitor and let it flow through a light bulb and light the light bulb. So the light bulb would flash. Now, the capacitor, unlike a battery, does not have the ability to continue to make charge. So once the charge is used up, the light bulb that flashes off. And if at that point we then go back to closing the switch here, we charge the capacitor and can repeat the process. Now, if these switches have voltage thresholds, which transistor devices allow that to have, so you can actually have both of these switches in one device and both of them are voltage dependent as to when they open and close, then we can very easily get a flashing blinky light system, and that is absolutely what is used anytime you'll see any type of electronics that have flashing lights. There's some type of capacitance that is being charged and discharged. So we're building our vocabulary, building our understanding little by little, and we will continue on.